Hello everyone, it's me again. I am Les. I am a master student in nanotechnology and I am going to see the chapter number 11 of kreyszig book of application of maths, and also it's chapter number 11 section 4 to 6. Okay, so as we saw in the previous videos, we saw that the this chapter is talks about one approximation, that is the Fourier series. It's the Fourier series is used to do a lot of applications in the life, in the in a lot of application in electronics, in industry, etc. So to verify the approximation, we saw that we always need to have a function, but it's a very determinate function. It's a function that is continuous and is also have a periodic. Okay, so we are going to see the chapter number 11, module 4, from 4 to 6. This is the second part. We are going to see the approximation by trigonometric polynomials. Okay, I'm going to move the camera to look better. So, okay, yeah. Okay, we are going to see the approximation by trigonometric polynomials. So in this case is from minus p to pi, obviously. So we are going to figure to have a function fx, and is a0 plus n equals 1 to n, of na cosine of nx plus bn cosine, sine of nx. Okay, this is the Fourier series. So we are going to have this approximation that is different from this. We have capital letters of A, so the difference is we have a capital letter in the coefficients of the Fourier series. So we are going to see for what is to have these two kind of Fourier series. The difference radicates to validate the error, because we want to have the less error. Obviously, if we have more and more n's values, or values of n, we have a better approximation and have a less error. So we are going to calculate the error is equals from minus pi to pi is f minus capital F to the square dx. That's the formula of the error. Okay, so Okay, that is equals to have the integral between minus pi and pi of f to the square minus 2 times f times f plus capital F to the square dx. Okay, so we are going to solve it, and first the capital F from minus pi to pi of capital F squared dx is equals to the integral of minus pi and pi of capital A0 plus the summatory of n of a cosine of nx plus bn sine of nx. Okay, all of these elevate to the square of dx. Okay, so if we solve it, we have that this is equals to a to a0 to the square plus a1 to the square plus an to the square plus b1 to the square plus bn to the square. Okay, so this is the answer for this. So we are going to solve it. Another, the other, the f to the f. So the integral between minus pi and pi of f dx, that is equals to have pi of 2a0 plus a1 plus an plus b1 plus bn. That's the answer. If we substitute this value and also have the Euler formulas, we have this. Okay, so for this, the error the error is equals to, let me see, to the integral between minus pi and pi of f squared dx minus pi of 2a squared a0 squared plus the summatory between n and n of an squared plus bn squared. Okay, so we are going to solve an example. See, example, we need to calculate the minimum square error of fx with n equals 1, 2, and 10 if we want. Okay? So fx is equals x plus pi minus pi x and pi. Okay? So first of all, we are going to see that this one is an odd function. Okay? So for this, the an term, we don't have an term. An term is equal 0 because it's an odd function. Okay, I am going to write here over here. Let me see. The formula of a0 is equals a over L 0 from 0 to L of fx dx, and Pn is equals of 2 over L from 0 to L of fx sine of n by x over L dx. Okay? So we are going to put the a0. A0 is equals 1 over 12, that is 2 pi. The integral between minus pi and pi of fx, that is x plus pi. Okay? So I am going to solve it. That is equals to, let me see, 1 over 2 pi and x squared over 2 plus pi x from minus pi and pi. Okay? So this is equals to 1 over 2 pi, and this is pi squared over 2 plus pi squared plus pi squared over 2 minus pi squared, because it's minus, let's see, yeah, let's see, 1, this is plus and this is minus, sorry. Okay? Yeah, this is minus and this is plus, because it's minus plus minus. And this one is got this read up from that, and we have 2 pi over 2 pi squared, obviously, sorry. That is equals to pi. And this is the first. Okay? Bn is equals to 1 over pi from minus pi and pi of x plus pi sine of sine of mpx over pi dx. This pi and pi is eliminated, so we only have mx. Okay? So we are going to solve it. Function, yeah. Okay. So for this, derivative of v is equal sine of nx. Okay, so for this, v is equals 1 over n cosine nx. Yeah? But this minus, sorry, minus. And the derivative of this one is dx. Okay? So for this we have the formula uv minus vu, no? v du. So uv, u x plus pi x plus pi plus times minus 1 over n cosine of nx minus the integral of v minus cosine of nx times du, that is dx. Okay? So we are going to solve it. Minus n cosine nx times x plus pi plus, this is the same integral, minus times minus is plus, cosine is sine, so it is 1 over n squared sine nx. Okay? Between minus pi and pi, minus pi and pi, all of this. Okay? So for this reason, the answer of this, we are going to check. The sine of pi is 0. Sine of pi 0. Sine of minus pi is 0. So this is 0. 0. For this obviously have a better, cosine of pi is minus 1 and cosine of 2 pi 1. So in this case we have a better. So for this can explain if we put minus 2 pi okay. So for this we have the final answer, that is calculate the error is equals this one, the error is okay. So the error is equals from minus pi and pi of f to the square of x, that is x plus pi to the square of dx minus the sum, minus, sorry, pi a0, that is pi, is 2 pi, 2 pi squared summatory of the answer that we have. That is 4 because we have 2 to the square is 4 of 1 over n square. So if we want to calculate, I'm going to erase this. If we want to calculate the hero minus pi of x plus pi dx, that is equals, we are going to see, is x squared over 2 plus pi x from minus pi to pi, and this is equals to this answer. I remember. Let me see. What's this one? So it's 2 pi squared. 2 pi squared. Okay. So we are going to solve 2 pi squared minus, this is a constant, but this one is minus pi 2 pi squared plus 4, and the sum of 1 of n squared pi. Okay? If we want to suppose the hero of 1, this equals that we have of 1. So it's 2 pi squared minus pi 2 pi squared plus 4 over 1. That is 4. Okay, that is 2 pi squared plus 4 plus pi plus minus 1 plus 2 pi squared. We have approximate hero 54.83. Okay? If we want to, I don't know, for the 2, it's 2 pi squared minus pi, 2 pi squared plus, this one is okay, plus 4 of 1 plus 1 over 2 is 4. Okay. 1 plus 1 fourth plus 4 plus 2 pi squared times minus pi plus 2 pi squared. Let me see. I know. solve it is minus pi and pi from the of x squared plus minus pi and pi of 2 times x pi plus minus pi and pi of a squared dx. Okay. So this is equals of the square of minus pi and pi plus pi is x squared. See, I have pi from minus pi and pi plus pi squared to square x from minus pi and pi. Okay? So we are going to solve it. So we are going to check it. So this is pi to the power of third minus this is eliminated. Let's check. Maybe this one now. Okay. So we have pi squared minus pi squared plus pi squared pi minus pi squared minus pi. Yeah, this one. This one is eliminate pi squared pi to the third minus times minus is plus, so is 2 pi to the third. That's the answer. Okay, for this integral. So pi to the third minus pi from 2 pi to the square plus 4 1 over x squared. Okay, if we want for the one, then it's 2 pi to the cube minus pi of 2 pi to the square plus 4. So we are going to check it. It's 4 times 4 plus 2 pi to the square times minus pi 4 plus 2 times to the square plus minus pi plus 2 pi to the cubic. Ahora sí me sigue dando. Como si sale muy grande esto, ¿no? Me sale pi al cubo. Sale 2 pi al cubo. 4 plus the other plus 4 times 1 plus 1 quarter. So we are going to solve it. So it's 1 plus 1 quarter plus times 4 plus 2 pi squared times minus pi plus 8/3 of pi to the cube. So the answer is 4.96. If we see have a better error, if we have a two ends, if we have a 10 ends, we have a better error or a minimum error. Sorry for that. Okay, so we are going to solve another example of, we are going to see another theorems. So we are going to see the storm liable problems. That is the orthogonal functions. Okay, we are going to see that the previous is the orthogonality, because all these instances of the Fourier functions are the orthogonalities, and the coefficients we have like the Euler's formula. As we saw in the previous videos, we can solve ODEs and solve with these ones. So we can solve second derivative of these bxy derivative plus qx plus lambda ry y equals 0 between a and b. So we have k1 of y plus k2 of y, x equals a. Sorry. So we are going to solve an example. Find a function of the storm okay, so we are going to see okay, so for this one, P let me see, R is equals 1. From this, K1 equals L1 equals 1. And K2 equals L2 equals 0. Okay? So, and also we can see that in this case, A is equals 2 and B is equals pi. Okay? Okay, so for B, for lambda equals B, B squared, the solution or general solution is equals to gx of CE. Let me see. C1e dx plus C2e minus bx. So this is minus b squared. So for this one, C1 equals C2 equals 0. For this, the eigen function doesn't exist. Okay. If we have that lambda equals 0, we have the same one for this, the eigen function doesn't exist, and if we have this, the ODE, ordinary differential equation solution or general solution, is g of x is equals, and we are going to see that is very familiar because we have a cosine of bx plus b sine of bx. Okay? So for this, g0 is equals a, and g of pi is equals b sine of b pi. That is equals 0, because sine of 0 of pi is 0. For this is 0. And for this we have v0, y equals 0. For this doesn't exist. Okay? So if we have for the eigenvalues of b squared, that is 1, 4, 9, and 16, and b equals 1, we have g of x equals sine of bx, that b is equals of the square root of lambda, that is equals of 1, 2, and blah blah. Okay? So the eigen values are lambda is b squared, that is equals b is equals 1, 2, 3, and the eigen function is y of sine bx. Okay? So we are going to see another subject. are a bit different from n. Okay? And the norm is equals of the square root between a and b of rx y squared n x dx. Okay? And the orthogonal series generalize of Fourier series. Okay, so we are going to see the orthogonal series that is f of x is equals of the summatory of n equals 0 a m y m x is equals a0 x0 of x plus a1 of x plus, and the x coefficient an is equals to f y m over of the normal of y m, that is equals 1 over normal y m to the square, and the correspond integral fx y m x dx. This is the Fourier constant, and the Fourier Legendre series is fx is equals of the sum of m0 of am pn of x, that is equals of a0 b0 plus a1 p1 plus, this is equals of a0 plus a1x plus a2 3 over 2 of a squared minus of 1/2 of x. So this coefficient am is equals to 2m plus 1 over 2, and the integral between 1 and 1 minus 1 and 1 of fx. Okay? So we are going to solve an example of orthogonal function. Example. We have ym of x equals sine of mx, m equals 1, 2, from minus pi to pi. Okay? So for this, yn is equals of the integral between minus pi and pi of sine of mx times the sine of x. Okay? Dx. If we solve this integral, we have that this is equals to 0, that in this theorem set we need to prove that, and for this is equals 0. So it's very easy because we have an identity function that is equals of 1 over half of from minus pi and pi of cosine of n minus n of dx minus the integral of cosine of n plus n dx. This one and this one is eliminated. So 1 over 2. And for this is equals 0. Okay? So we are going to have the normal. Okay? So it is the integral of minus pi and pi of sine square of mx dx. That is equals, we have identity, the double identity of sine, that this is equals of 1 minus cosine of 2mx over 2 dx. Okay? So if we integrate this, we can put minus, okay, integrate this obviously of cosine 2mx dx. This, the cosine, to integrate is the sine. So for this we have minus 2 over m 2m of sine of 2mx from minus pi to pi. But this one is eliminated and we only have this, that is minus pi to pi. So this is, for this is equals to pi. Okay? So they are orthonormal. So for this, gm is equals to the square root of pi. And the orthonormal series are sine of x equals square root of b pi, sine of 2x so over sine of 3x, and these ones are the orthonormal sets. Okay, so this is the end of the video. I hope that all is understanding well, and for me that's okay. And see you in the next videos that we are going to solve more about the Fourier series. Thank you and see you next week.